Wow, those were the days. But a lot has changed since then. In gaming, in motorcycles, and in how we develop them. Today for bikes, it's all about rider assistance systems, connectivity, electrification, and safety at scale. At dSPACE, innovation never stands still. That's why we are proud to introduce ASM Bike, our new product for realistic two-wheeler simulation. And that's just the beginning. From sensor simulation and radar testing to validation setups for connected telematic systems and electrified powertrains, we keep pushing boundaries. Curious? Stay with us the next couple of minutes to learn about efficient testing without putting a real bike on the road. Reproducibility is already challenging for four-wheeled vehicles, but for two-wheelers, it's getting even more interesting. Hi, my name is Norbert. Welcome to our hands-on video for the first release of ASM Bike. Over the past months, we have received more and more requests like these from all around the world. As you might know, we love challenges like these. And our goal is simple: to support our colleagues and especially our customers in the best possible way. The two-wheeler market is evolving rapidly, combining riding pleasure with safety, increasing demands for flexible mobility in dense cities, and a strong push towards sustainable solutions. That's why we decided to expand our simulation portfolio into this domain. From a distance, simulating a motorcycle might seem simple. Just fewer wheels, fewer components, but that assumption is misleading. A two-wheeler system contains inherently stable, but also unstable regions. Phenomena like capsize, weave, and wobble can lead to instability or even loss of control. To properly evaluate the influence of components, the rider, stability systems, assistance functions, or the powertrain, accurate modeling is essential. That's exactly why we developed ASM Bike, a consistent simulation product for two-wheelers. As you'd expect, it's implemented in Simulink, fully open for integration, customization, and extension. The model includes a full multibody system with 12 degrees of freedom and 7 moving masses. You see directly, unlike cars, mass distribution is even more interesting. Every component must consistently be integrated as a separate body. Assumptions like neglectable mass effects cannot be applied to two-wheelers, as masses of wheels, chassis, fork, rider are of similar order. But that's exactly why we are here. And on top, it's flexible, from high-end motorcycles to lightweight scooters. Among others, a central component is the Pajeka Magic Formula 6.2 tire model, capturing large roll angles, which has been extended for performance symmetrical calculations. For real-time simulation, performance matters. That's why we use a rider algorithm based on optimal control to regulate steering torque, both via front fork and rider body. Once these aspects are mastered, we can achieve fully real-time capable bike simulations, including the option for extreme or even dangerous maneuvers, which should be prevented by the rider and safety systems in practice. But simulation models alone are not enough. What really matters is the toolchain. On one side, we support electrification, from battery models to CPU, or even FPGA-based motor simulation. On the other side, we focus on assistance systems. Let's take ARAS, Advanced Rider Assistance Systems, as an example. Having features like brake hydraulics up to traffic simulation for surrounding objects and fellows will enable scenarios for efficient validation. Depending on requirements, we provide radar test benches with the dSPACE Automotive Radar Test System DARTS, enabling turnkey full system integration without modifying any ARAS ECU. And with Aurelion, we bring everything into a realistic 3D environment, enabling physics-based sensor simulation like camera and radar to feed your control algorithm. But let's stop talking and have a look right into our product. So what you see here is Simulink, As I said, and as you know it from our ASM product family, it's an open Simulink model. On top level, we have our structure as always in ASM models. So we separated the different domains to be more flexible in the simulation setup. And below this subsystem, you will find later on the multibody dynamics of the bike. We differentiate between controller and plant. In the controller, we integrate our own soft ECUs. In there, you will also find the interfaces for your controller. The plant is below these subsystems, also containing the complete multi-body calculations, which are inside this subsystem. But this is not that interesting now for the parameterization itself. For the parameterization, maybe, let's go in the suspension system. Here you've got a suspension for front and rear. You see here the workspace structure from our parameters, which are then used also for the initialization and the parameterization itself. And as you know it from ASM models, it comes with a help which explains our mathematical approaches, the parameters, the imports, outports, the units, everything which you require to understand our implementation, to make your own adaptations, modifications, extensions as you require it for your project. But speaking about the simulation is one thing, the parameterization is very important. For this, we have the tool ModelDesk. ModelDesk will give you access to all the parameters inside the simulation model. And as I was navigating in Simulink to the suspension system, I will do the same now in ModelDesk. So we have the bike, and you see you will be guided through the GUI to the corresponding system you are now focusing on. Let's take also the suspension system as before. And here you have all the required parameters for the system to calculate displacement, to calculate forces. And the parameters are then serialized in an XML file, which gives you then the possibility for parameter management, parameter administration, to generate your own variants for different bikes, bike types, bike projects. And this is then administrated inside ModelDesk. So I already downloaded the bike model with a corresponding traffic simulation to VEOS, to our offline simulation platform. And to see the simulation, we can open ControlDesk. So this is ControlDesk. With the ASM Bike product, we prepared dedicated layouts to give you a good start, a smooth start into your bike project. You've got the dashboard, you've got instruments to visualize the bike states. You have access to the simulation variables, and you can start the maneuver. So this is now a highway maneuver. We are accelerating the bike and approaching a vehicle. The bike model will then try to overtake the vehicle, but there is another vehicle coming from the back. We have a map layout here, which then shows you the trajectory of the bike, which is currently driving on a highway near to our headquarters. And to get a deeper impression of what is happening in the simulation, of course, we have our tool Aurelion. So you already see here in Aurelion that we approached this vehicle, and as soon as the bike detects the vehicle from the backside, it will try to secure the situation. But I will restart the maneuver again to also give you an impression of the sensor outputs, which can then be passed to your control algorithm, to your rider assistance systems, for example. So I placed a camera sensor at the rear of our bike, and with this camera, sensor. We will calculate the video feed, the video information, which is then passed to your control algorithm. Of course, you can apply now color filters and so on, everything required to fulfill the protocol between the camera sensor and your control algorithm. And yeah, what is also interesting is maybe the green boxes, the green dots. So these are additional sensor information calculated on the processor side. So next to our 3D physics-based sensor simulation, we also calculate ground truth information, the object information to fill object lists. Here, this the nearest point of surrounding vehicles, which is also required for several situations and scenarios with assistance systems. And having then the Simulink model, having ModelDesk for the instrumentation and Aurelion for visualization and sensor simulation, we have everything you need and prepared to start your bike project. From parameterization to simulation, from control integration to automated testing, everything is available in one consistent environment. With release 2026A, ASM Bike becomes part of the ASM product family, providing the foundation for multibody simulation of two-wheelers. Open, scalable, and ready for mill, zill, and hill. I hope this gave you a solid impression of ASM Bike. If you have any questions, reach out to your local dSPACE contact or directly to me. We are looking forward to your challenges.